Hey,
You hear me fine?
what was that?
Oh, can you hear me okay?
So far, so good.
Okay.
Sorry.
All right. So Sadie said she might be a bit late.
Okay.
Um, what do you guys want to do? Do you want to wait a little bit, or
We can wait maybe like 5 minutes and
you want
then
to give her
see if
5?
she gets
Okay,
it.
that
Yeah.
sounds. I'm gonna turn my dishwasher off. It's kind of noisy. Well, not. It's noisy.
I'm gonna go lock myself in here so they're not going in a second.
Oh. Huh?
So Jesse, where are you from?
What's that?
Where are you from?
Oh, I live in. Well, my husband and I live in Murrieta, California.
In where?
Murrieta?
Maria. Okay.
Yeah. Do you know where are you at?
I'm in the Monterey County.
Monterey County.
Yeah.
We are like if you go the furthest north you can go in San Diego County and then Riverside County. Me.
Oh,
That's where we are. Temecula is right there, Temecula Murrieta. So right there. We're no longer San Diegans. Ah, there's Sadie.
Hey.
Everything okay?
Yeah.
Okay, good. Alrighty.
Okay.
Let's see. Part 2. Okay, you guys ready to get started?
Yeah.
not windy, but what can we do?
Okay. Part 2. Okay. So did everybody do the sample mean standard deviation for part 2 already?
Yes. I'm sorry.
Number 7 said to go in an SPSS or Excel and create your computer.
Yeah.
Do you need help with that, Giselle?
Yeah, I do.
Okay. You want me to walk you through it?
Yeah.
Okay. Do you have SPSS up?
No, I was gonna get it ready, so I turned on my other computer where I have it. I used it. I forgot. Like, log in.
Let me know when it's up and then we'll walk you through it. I think I'll just close out what I've got and then, well, no, I'll just open a new one. New data file. There we go.
Maybe I had a hard time, like, you know how it asks you if you just wanna open existing data or plug in your information.
Okay.
I didn't know, like, what to do there.
Oh, you mean to taking the values
Yeah.
from the preparation assignment and like where to put them?
Mhm.
Okay, yeah, well, that's pretty simple. We can go over that.
It's taking a while to open. I don't know why.
I think it's just one of those programs.
Okay, so do I say type in data or run an existing query?
Type in data, I would assume.
And then
Okay, so
how do
oh,
I
go ahead. Sorry.
Uh-huh.
What were you gonna ask?
Oh, just how do I plug in the values? Like
Okay.
what's out there?
You want me to screen share so that you can see?
Yeah.
Okay. All right. So here's my. Is this what you're seeing? Your data sheet. Can you see that?
Yeah.
Okay. So basically, you're just gonna go into our preparation assignment doc, and you're gonna copy all those values, right? Those numbers, and then you want to come here in your first box under variable. VAR stands for variable, and you're just gonna paste, and bam, there's all your values, right?
So we had one of those in our homework. I didn't even notice.
Now,
The way.
because all of these are whole numbers, what you can do to get rid of this decimal place is to double click on that top, and see how it brings up your variable numeric with decimals. I want to get rid of those 2 decimals. I just take that to 0. See that? And then I can go back down to the bottom here and click data view, and bam, my decimals are gone.
Okay.
I don't know if that's necessary to do, but if you need to do it, that's how you do it, because all of our values are just whole numbers, you know. Okay, so you ready to go from here?
I still don't know where we got those numbers from.
Okay, so these numbers came from our assignment, our lesson 11 preparation assignment. Part 2, and it's the first part.
Oh.
See all those numbers there?
Mm-hmm.
The study by the National Association of Realtors reported.
Okay.
So those are the numbers you're going to copy and paste.
Okay. I'm sorry, I actually have to like do them by hand because it would take me to like another computer. I don't know. I don't know if I can copy and paste them.
Yeah. Okay. So when the 2 of you created this, did you guys do the t-test?
Yeah, I went in to analyze and then compare means to one sample t-test.
Okay, cool. Yeah. All right, and then we'll
walk. In the textbook anyways.
Yeah. All right. Giselle, just let me know when you're ready to go to the next step.
All this, I'm like trying to digest all this stuff. I'm like, but a bit too much for me this time.
Do you know how to copy and paste?
I know how to copy and paste.
Okay.
I don't know if I can. If I'm logged into a school computer from.
Oh, I gotcha. Because you've got your your document up on one computer and then your SSPS on the other. Okay, so you have to hand type it all in. Okay, I hear you.
Okay, so I type them all in.
Okay. All right, so now you can go click on Analyze up at the top. Hold on. Let me screen share my entire screen. I don't know if you're going to be able to see this. Okay. How's that looking to you? Can you see? Or is that just a bunch of junk too difficult to see?
Analyze descriptive statistics, explore.
So you're gonna go compare means. You go analyze, compare means.
Analyze.
And then you're gonna click on one sample t-test. I don't know if you can see that on my screen or not. Oh, I didn't hit share, sorry. Okay. So analyze. I don't know if you can see that or if it's too tiny. Compare means. One sample t-test. And then you just move your variable over, the only variable that's there. And let's see what options does. You can change your confidence interval, but I don't think we need to change our confidence interval for this one, right? Is it 95 already? Anyway, we'll just hit cancel. And then hit OK, and then that should create your t-test. And it should give you your mean and your standard deviation. Now, just so you know, this 95 confidence interval down here is different from the actual one, so I think we're just supposed to ignore this one. Right, ladies? That's what the note said, like the caution note in the book. But right here is what you want. Did that pop up for you, Giselle?
Yes.
Okay, perfect. All right, so we can move on. Then I'm going to stop screen sharing. There we go.
I'm sorry, girl.
No, you're fine.
You know, I tried to figure it out with the reading first, but it was the same thing. I didn't know what to input.
Sometimes you just gotta see it. I'm a really visual person, so I have to like see it. Okay. All right. So what'd you get for your sample mean?
46.73.
And standard deviation?
8.83.
Okay. Perfect. And do you see that, Giselle?
And where it says one sample statistics there, or one sample test?
Yeah, on your T. Let me bring mine up.
Yeah.
Yeah, under one sample statistics. Yeah, and your mean is right there, 46.73, and your standard deviation 8.827, which rounds to 8.83.
Yeah.
Okay, perfect. All right. Okay, so moving along.
Sorry, my thing keeps crashing. My system keeps crashing. So let me see if I can work it out. But I did it before, so.
Oh, okay. Okay, so it says, what are the requirements for creating a 95% confidence interval?
Sample and
oh, Giselle, you're breaking up. You might have to put your headset on.
Can you hear me? Is this better?
Yes, that's better. Thank you.
Okay. All right. So it's the same things as the other, right? The simple random sample and having the normal distribution.
Yeah, and the X or the
Mm-hmm.
X
For
bar
the X bar.
normally distributed. Yeah. Okay. Cool. You two are quiet.
Sorry, it's not. My computer's not, and it keeps shutting down both my computer and the Google Hangout.
That's not good.
I don't know if I keep disappearing off of your Google Hangout, but it shut me out like 3 times already.
Oh no.
Let's hope it doesn't keep doing that to you. Okay. All right, here we go. Number 2. With the data above, create a 95% confidence interval to estimate the mean age of all clients who buy an investment property. Put the numbers you computed in number 7 of part 1 into the confidence interval formula. Show your work below. The t-score for a 95% confidence interval from the t-distribution with 14 degrees of freedom is 2.1448. Make sure you do not overround while making your calculation. Okay, so I guess they want us to do it by hand,
Yeah.
right? With that that formula. Where is it? X bar minus t over the sample standard deviation divided by the square root of n, right?
Mm-hmm.
Yeah.
Yeah.
Where did my computer go?
All right. So the t-score for a 95% confidence interval is so it's going to be 47, or 46.
What are we subtracting by?
So we're doing, so our X bar is 46.73, right? Minus
Oh, so,
our,
okay, sorry.
minus,
I put 47, sorry. Minus?
minus our t-score, which is 2.1448, right, ladies?
Yeah,
Yeah.
that's what I was thinking.
And then divided by our standard deviation, which is 8.83. And our sample size is, let's see. It wouldn't
15.
15. Okay. By the square root of 15.
Yeah.
Okay.
Oh.
It's, I don't know if I get it right. It's at 41.8419. I guess rounded up is 41.842.
Oh, hold on. Oh, is that your answer?
Yeah,
Oh, hold on. I'm not quite there yet.
it's okay. Well, I'm not sure I did it right on the calculator.
Well, I got
think I
40. I got 41.84 and 51.62.
I got the same as Sadie.
Yeah, 41.
Okay.
What they show on SPSS as well.
Oh, good.
Oh,
I didn't do the other one yet. What?
46.
Yeah.
Okay.
And it's the same number that's on the answer sheet.
Good. Then I did get it right.
Good.
Okay. Is it 51 point? Oh, 51.6. Okay. Okay. Cool. All right, so we got that right. Moving on. Now create a 99% confidence interval to estimate mean age of all the clients who built an investment property. Follow the same rounding rules as above. The t-score for a 99% confidence interval from the t-distribution with 14 degrees of freedom is 2.9768.
So we
Now-
just use the same number and change t, right?
Yeah. So it'd be 46.73 minus the 2.9768 divided by 8.83, divided by the square root. Oops, 8.83 divided by the square root. So we know this number. 2. No, 96 times 2. Okay, what'd you guys get?
I'm still figuring it out.
Oh no, that's okay.
We're doing 3.
Yes.
And we're multiplying. I'm sorry. It's 46.73 plus or minus 2.9768.
Uh-huh.
Okay, then I got 39.944.
Uh-huh. 39 point, and then 53.51
Yes.
for the 39.9 and 53.
Yeah.
That's what the answer key says. Excuse me. Okay, number 4, we get to use the software. Sadie, you ready to move on to 4?
Yeah, I'm ready.
Okay, sorry. Just didn't hear you. Okay,
No,
so
I'm
now...
I'm hearing. I thought of that.
Somebody has an echo.
What's that?
Somebody has an echo.
All mine are closed out.
Yeah, so are mine.
Okay, so I don't know. Oh, never mind. I'm hearing myself.
Did you close out all your tabs other than the Google Hangout? Okay. And Sadie, you said you were having a hard time hearing?
Yeah.
Yeah.
Is it me or is it everyone?
Um, I can't tell.
Well, no, no.
I'll
Stop.
mute mine because I think it's coming from mine.
You're nice and clear. I can hear you nice and clear.
Okay, because I echo on my side.
You and Giselle are echoing?
Yeah.
Yeah.
All right, well, someone's got an extra... Someone's probably got a tab open. Let me check and make sure it's not me. Not me. Everything's closed down. Close that.
I'm doing it through my phone.
Oh, that's probably why. Don't worry about it.
Okay. All right, so we're going to use Excel or SPSS to do this number 4. Compute the
I did it along with
What was that?
with our work. I did it along with the work that we were doing.
Oh, okay, so you already created it in Excel instead of doing it by hand? Okay. Giselle, do you need us to walk you through that?
I do.
Yeah.
Screen share? Okay, I think that's just the same as we would create. Let me bring myself. What, Miriam? Okay. You know what? Can you just wait? Okay, just watch Mickey Mouse Clubhouse with Sissy. No. Well, I'm in the middle of something right now. You're just gonna have to chill. All right. Let me bring up my data here, and I have 2 of these. We don't need 2 of these. Okay. You guys want me to screen share, right?
Yeah. That'll work.
Okay. When I do the entire screen, is it too much stuff for you guys to see? Or does that work? Can you see it, or is it like too small? Well, I'll just do this one since no one's really answering. Okay, so we're gonna go analyze, and I'm pretty sure it's the same thing. Descriptive statistics. Sorry. Where are we? Descriptive statistics. And I think isn't it just explore? It's the same thing that we do to create a histogram and all that. I'm going to move my variable to the dependent list. And here we go. And you click statistics. Can you guys see that? Is that coming up on the screen at all?
I see a table, but that's all I see. I don't see what you're doing with the mouse.
Then I must need to share my entire screen. Let me share the entire screen because that's not working. Let me stop sharing that and then do the entire screen. Okay. I don't know why, because, okay. All right, so I have my data here. Can you guys see that? Let me close this down so it's not so crazy. And then I go analyze, descriptive statistics. I gotta talk slow because for some reason I can't talk. Explore. Okay, so here comes my box. Can you guys see that? Is that better? Make it bigger?
I can't see any.
Okay. Is that better? Can you see it now? Nice and big?
Okay, I can see it now.
Okay. Here we go. Woo! Okay, the entire screen. How's that? Now can you see it?
Kicked out, I think.
Huh?
Lovely got kicked out. I don't see her.
You don't see me at all? Okay, well, I have to be talking.
No, I see you. I don't see Lovely connected. Sorry.
Okay, so I'm going to click my variable. I'm going to move my variable over into the dependent list. Right? And I'm going to click statistics. See that little box there? It says explore statistics. Yeah? No?
Yeah,
Maybe so? Okay. So right here where it says descriptives, you just check that box, okay? You're going to change your confidence interval for mean, right? See that?
Okay. Yeah.
And we want that to be what now?
95.
95, and it's 95, so we're fine. We're just going to go continue. If otherwise, then we just change it to 99. So continue, and then we're going to come down here and click OK, and now this will create my data. And here's my data. See that? And now it doesn't actually make it larger, but at least it'll cover up everything else that's on my screen. So here's our upper and our lower bound right here, our 95% confidence interval, right under where it says mean. You see that, Giselle?
Yeah.
Yeah?
Yeah.
Okay. So it's just the same thing we would kind of do to when we were going through and creating the 5-number summary, all that. It's the same steps. So I have a 41.84 and 51.62. What is our 41.8 and 51.6?
Hold on.
So now we'll just go in and do this again, but change that confidence interval to 99, because that's what it wants us to do for letter B, right? So we'll do the same thing. Analyze, descriptive statistics, explore. Our variable's already there. Click statistics. Change our confidence interval from 95 to 99. Hit continue. Click OK. Bam. And there is our 99% confidence interval. Upper and lower. 39.95 and 53.52. 39.9 and 53.5. Okay. I'm going to stop screen sharing. Is everyone good on that?
Yeah.
Giselle?
Yeah, I'm gonna have to practice a lot more, but I have seen how it's done, so I will be able to do it.
Well, just write down the steps. Do you have the steps written down?
Yeah, I have that written down.
Yeah. Oh, you do?
And it's under reading, how to do it.
Yeah. Okay. Well, we get to move on to 5?
Yes.
Yeah.
Okay. So how does the margin of error for the 95% confidence interval compare to the 99 interval? So
the 95% confidence interval is smaller than the 99. But the 99% is the 95.
Yeah. Wait, right? 93.
Yeah. Because you, a 95 you go from 49 to 51, and 99 to 39 to 33, so you are covering an area.
39, 40, so that's 16 points. That's far. So there's a 16-point difference between the 99 and a 10-point difference between the 15, or the 95, right?
Yeah.
So that would make, now when we're talking about that, are we talking about the range, right? Between the points, between the 2 points?
Yeah. So yes, 99 is gonna be, if you picture the bell shape, 99 is gonna take more space to say, okay, I'm 99 confident that it is between here and here. Well, with
Okay.
we're gonna be like, it's gonna be from here, it's gonna be smaller.
It's a simple concept. I don't know why sometimes my brain just kind of doesn't get it.
It's hard to get it because we think 99 should give us more confidence in a smaller way, not the bigger way. You know?
Okay, yeah. So the answer for number 5 says the margin of error for the confidence interval is smaller for a 95% confidence level than the 99. Right?
Yeah.
All right.
Okay.
All right.
Sorry,
So- You're here. I can see you. I think we just lost Sadie, though.
Oh man.
Yeah, so we just to now.
Well, I'm having difficulty hearing you, Giselle.
I was to asking if you wanted to go for again with us because Sadie just got disconnected. Others say.
Oh, here we go. She's back. Okay.
Yeah, I just can't understand.
You can't what? Sorry.
Well, I'm getting five of what everyone is saying. It's really hard to hear.
Oh. Getting a lot of feedback?
Yeah.
Anybody else still getting feedback?
Yeah.
I'm still getting that.
Giselle, are you still getting feedback?
Yes.
Maybe it's me, but I'm the only one that's not. I'm hearing everybody pretty clear.
I think it's Google being weird with their connection.
Yeah, because everything else is closed down, so. Alright, well, let's move on to 6. Rather than estimating the age of his clients that buy investment properties, the realtor agent would like to test the claim that the age of his clients is different than the national average of age 47. Use the 0.05 as your level of significance. Follow the following sequence of steps. Fill in your answer at each step and show all your work. Okay.
Basically, say the normal and we try to
Yeah.
which is the null would be mu equals 7. Alternative would be mu does not equal 47.
Yeah.
So what are we saying?
What's that?
What are we saying? Are we saying all is 47 and not 47?
Yeah, not equal to 47.
Not equal to mean going higher and lower, not higher or.
Okay, so compute the test statistic. First, compute it using the formula and showing your work below. Then check your test statistic by inputting the data into the software. Okay, so what's our formula for that?
So it would be E equals 4673 My next 47 divided by 8.83 over the square root of 15.
Okay, so it's that one. T equals. Hold on here. All right. So we have. Okay, and we're just using all that data we were using before.
Yeah.
46
From the
minus 17.
So what equation do you use? But what is the for x bar mu?
Oh, it's. I think we're just using what we used from part 2. The sample mean and the sample standard deviation from when we plugged in all those numbers.
So is it going to be 7.3 minus 47?
Uh-huh.
Okay.
Divided by 8.83 over the square root of 15.
Did you guys get negative 1.184?
negative 0.118.
Go check on Sissy. Go check on Sissy, please. Go check on Sissy. Please go check on Sissy.
Yeah, I got negative 1.184.
All right. What'd you get again?
I got negative
Negative 1.18, right? Okay. All right. Cool. So that's correct. Negative 1.18. And let's move on to, okay. State the degrees of freedom. Oh, which it would be 15, right?
14.
14. Because it's n minus 1. Yeah.
Yeah.
14. Okay, so 14 is the degrees of freedom. Sketch the t distribution and shade the area which represents the p-value. Yeah, I'm not quite sure how to do that.
Me neither. I wasn't So do we want to see and then come back because each yourself is the p-value. If we know the p-value, maybe we get a better idea on how to sketch it.
Yeah, probably. Right? And shade the area which represents the p-value. Yeah, because we don't know the p-value right now, right?
I don't think so.
Sadie, Natalie.
I'm sorry. Look at the book.
I think I'm just confused on how to sketch the t distribution because we don't have we're not using the applet.
Well,
the t distribution is
number 2 in
the bell shape, but not as perfect.
Yeah. What were you saying, Natalie?
It says at the reading. At the with well, it's sketches or not. Yeah, it's a number two.
Are you just looking at those? I think I see what you're looking at. The one where it says the degrees of freedom is 1, 5, and 15.
Yeah, and I'm just looking at those. I'm thinking it's not the same thing.
Okay, so
So
maybe this is what. Okay. Let me try to draw it. See if this is what they mean.
So it would probably be close to that third one there, right, Natalie? The distribution with the degrees of freedom of 15. So it would be really close then to the normal.
Yeah.
The normal curve.
This one over here is your regular one. Oh wait, you can see it. Can you see that at all? So let's say this is the regular one, and then that would be like the 14. Is that what they mean?
I think so, like just a bit under it. If you look at the book, with the 3 illustrations, like Natalie said, under number 2, the 15 is really close to that normal distribution curve.
Do you also have in the reading it says click here to explore how to change the distribution changes with a degree of freedom. Do you guys have that?
Oh yeah. For some reason that wouldn't work on my computer. I don't have a plugin that supports it. I forgot to ask my husband about that.
Okay.
I gotta ask my husband about that.
Very far away.
Okay. All right. Well, I guess let's just move to E and compute the p-value. Right?
Yes.
Which haven't we already done that basically?
You have 9.8073.
Oh, hold on. I think I hear my daughter crying. E. P-value. Where's my p-value?
Do you guys have your Giselle?
I don't think I see it.
Where are you finding the p-value?
Well, I need to Excel, so Excel just gives it to me. Once I plug it all in.
Okay. Mean, median variance, standard deviation. Frequency. Why am I not seeing it? Is there a different way to do it in SPSS?
I can share my screen. Is that where maybe?
Oh, do I need to create a histogram maybe? Let me go in and create a histogram and see if that does it. Why do I keep clicking that? No. Alright. Huh?
Can you guys see my screen?
Oh, I can see it.
Histogram.
Right on this side, the p-value here. Can you guys see it?
Let me see. Let me mute my mic. Natalie, can you do that again? You need to talk so that your screen shows up.
It doesn't show up if I don't talk.
Yeah. Otherwise, whoever's sound is coming through is the one that's going to be on the main screen.
Okay, perfect. But you know what? Now that I noticed, the p-value that they give me is not the same one as the answer key. I'm not exactly sure how that works.
It's because we would need to compute the last three numbers of E. Like but it's computer.
Okay, why is my brain not working? How do we compute the p-value? Anybody have a clue?
I'm trying to figure it out.
Okay, find the p-value and compare it to the level of significance. Okay, let's see. Ow, 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 ow. Oh, yes.
Oh, there.
Okay, I remember going through this yesterday and not having a problem finding the p-value. Good job, Olivia. It
Okay,
says
so that E minus 1 is notation.
yeah, it says the p-value is given in the software, but why am I not seeing it in the software? You know what? I'm gonna close this out. I'm just gonna do this from scratch. One, 27. Sigma two-tailed. Okay. Oh, that's what it is. Okay. So in the one sample test, all right, let me do this again. So I'm going to go analyze, compare means, one sample t-test. Okay. The Sigma two-tailed, I think that is your p-value right there. For those of you who are looking at SPSS.
I have zero.
Okay, so what they say, you have to double-click it. Because in the notes here it says, if the value of, let's see, of t is large enough, SPSS gives the value of Sigma two-tailed as 0.000. By double-clicking twice on this cell, SPSS will display more digits. So you got to go in and double-click on it.
Yeah,
It's
because
still-
because it is the sensation. It's showing you that that number from 10 to the 11. And so it will convert it to 0 point, a bunch of zeros, and then 980739. How many zeros is
Okay, but when I double-click on it, it says 7.6723E minus 12.
It's supposed to be 0.077.
Sorry, Natalie, I couldn't understand you.
Sorry.
Yeah, me neither, Natalie. Sorry.
Can you hear me now?
Yeah, that's better.
Okay. The answer is 5.077.
Yes.
And so something close to it, 0.85. But I only had it because I changed a couple numbers on the data. Null hypothesis, I changed it to 47.
I've got something completely different.
I just have zero.
What do you?
It's pretty much zero. It's pretty
Did you double click on your Cigna two-tailed on your one sample test?
Like 8 zeros behind it.
Why do I have something different? And is everything else your?
Yeah, everything else is the same.
Okay, so then maybe I don't know what's going on with mine. Okay. Well, should we just move on?
On the reading, it tells you on the SPSS instruction how to do it.
Yeah, but for some reason I don't know why mine is coming up different. I have all that. So we go. Our confidence interval is still 95, right?
Yeah.
Okay. Analyze descriptive statistics. No, compare means, one sample t-test. Oh, I forgot to put the test value in. That's why.
Did you put that, the null hypothesis at 47, and the test was not equal to?
Test value is 47, right?
Yes.
Okay, maybe that's what I forgot.
I forgot to put the test value in. Okay, 47. Okay. There we go. And that looks a lot more like what it should look like.
Perfect.
It's giving me 0.9085.
That's what I have too.
Okay. I don't know why it's different from the key.
I think the key just got it wrong.
That's always helpful when the key is wrong.
Last time it was, remember?
Right. Okay, that makes a huge difference. Gotta remember to put the test value in, and then everything else looks the same. Except for my t is 1.1 or negative 0.117 instead of negative 118.
Yeah, that's it.
Yeah, but in the key it says it's 0.118.
Oh, does it? Yeah, that's right. Okay. But I don't know why the software would get it different. And then the hand computation. But whatever. Okay. All right, let's move on. Woo! Figure that out. Okay, so state your decision. Do you reject the null hypothesis or fail to reject? So is our p-value greater than or less than? It's greater than, right? So we would then
Fail to reject?
909 and 0.05. Hold on.
We don't reject more than 0.5.
Yeah, yes, I see. It's okay. Just let her do what she wants. Okay. What does the note say? So, because the p-value is less than A, we will reject the null hypothesis. The p-value is greater than A, we fail to reject. So we're going to fail to reject, right?
Mm-hmm.
Please. Okay, fail to reject. All right, G. Present your conclusion in an English sentence relating the results of the context of the problem. So there is not enough evidence to state that the mean average or the average age is different than, right, our null hypothesis. Sorry,
Yeah.
not making any sense.
No, that actually makes sense. Yeah.
Okay. Key says, we have insufficient evidence to conclude that the mean age of the realtor's customers who are buying second homes is different than the natural average.
Which is basically what you said.
Okay. All right. Are we ready for the test?
No!
I feel the same way. No.
Yeah,
All right.
this one I was like, I read reading it up times. Yeah. It took me a while, and I was still like trying to digest information.
Right.
How do you do so well for the back in section on the last page, and you let me repeat it. So if we do wrong, I think we create enough A's as a group that we let it.
Oh, you're hard to hear again, Natalie.
Is it hard?
You speak really slow.
I'm sorry?
There you go. I can hear you better now.
Let me try to face this. That's okay. I'm going to start with
Going down?
Are you all ready?
You guys want to watch the ABC song? Yeah, ABCs? Sorry, I'm just going to set my girls up with a little bit of distraction.
Oh yeah.
What are you making a hamburger? You guys want to watch the numbers? Song, the letters? What are the numbers? ABC? Oh, look at song. Okay, ABC's this one? ABC song? Alright. Great job. Okay, sorry. Alright, so number 3. You guys ready?
Yeah.
Oh, hold on. I'm having the Sorry, it's coming up. Okay. Okay.
Okay, ready?
Yeah. Yeah.
All right. So number 3, in previous lessons, we have assumed the population standard deviation was known. In this lesson, we are making a different assumption about the population standard deviation. What has changed?
It's unknown.
Unknown.
Yeah, that's what I say. Everyone agree?
Yes.
Yes. Yes.
Okay. 4. The null hypothesis and the alternative hypothesis and the population standard deviation is not known. Becca collects a sample size of n, 9, and computes the x-bar at 11, and s is 6. Use the information for questions 4 through 5. Is the population standard deviation known? No, right?
No. No.
What is the value of t? Okay.
Did anyone else got that 1.5?
Sorry, I'm behind. Not done yet.
What was that again?
Sorry. Yeah, 1.5.
Yeah, I got 1.5.
Round to 1 decimal point. Okay. Using the following values, which were pulled from the data file body temp, copy and paste them into the software you are assigned to use. Using the null hypothesis of u equals 98.6, an alternative of u is less than 98.6, and the level of significance at 0.5 or 0.05. So what is x? Okay, so we gotta open SSPS and plug all this stuff in.
Yes.
Oh, no. I don't want to highlight everything. Come on. There we go. Come on. There we go. Okay, so now we're gonna go. Analyze your means, test. So our test value is 98.6, correct?
I got 98.2.
Did everyone see the Yeah.
Okay. So our sample mean is 98.22.
Hold on, I need it. Okay.
So what was C?
We haven't agreed on it yet.
Yeah, well, I need to change my test value. I still had it at 40. But I guess that doesn't mean
Natalie, did you get the mean?
I got 98.234.
98 what? Okay, 234. I got 98.22.
that's what I got.
Oh wait, give me a second. I got the wrong number. What did you get? I'm sorry.
98.22.
Okay. I got 98.2.
98 point what?
98.234. That's what I keep getting.
And you're using Excel, right?
Yes.
98.234. 234. I don't know. Maybe. And 98.22. I don't know. I'm gonna put 98.220.
That's what I'm gonna put as well.
Okay.
And what'd you guys get for your sample standard deviation?
0.992.
Yeah, 0.92201. That's what I have.
Yeah.
Natalie, what do you have?
What was it?
What do you have for your sample standard deviation?
I have 0.73.
Sorry, say that again.
0.73.
2.73?
No, 0.7. I'm pretty sure.
0.7. Boom. So, why is it so different?
I don't know. I got 0.992.
Yeah.
Okay.
So round point 0.922. Okay.
What did you say?
For our standard deviation, we got 0.922.
Okay.
And then the T-score.
Okay, what do you get for the T-score?
I got negative 1.843.
That's what I got as well.
Negative 1.843.
Yeah.
And what was 7?
0.992.
Okay, and then the p-value, which is your sigma two-tailed, is 0.081. Is that what you have? And Sadie?
I still have 0.
Say that again?
I just have 0.
0 for your p-value?
Oh, for my p-value. Yeah.
This it says the Cigna two-tailed.
Yep. I don't know why. I just can't get it to be anything other than 0.
Mine says 0.081. What? Stop. I don't like the way you're behaving right now. What do you need? Natalie, what do you have?
It is
What?
what did you get for the
I'm sorry, Natalie, I didn't hear you.
Okay, what did you get for your
T-score?
Yeah, number
Negative 1.843. Olivia. What do you want? You want to eat? Eat? What do you want? You want cheese? Some cheese? Do you want some cheese too? What do you want? Use your words. I don't like the whining. What? I can't hear you. I can't hear you. What do you want? I can't hear you. You want some cheese? Okay. All right, sorry. Have to appease the children's. All right, what are we on now?
What did you get for
.081.
All right.
Okay. So what is the correct decision based on the evidence? So our A was what?
0.05.
0.05. Okay. So 0.05 and 0.081. So 0.081 is greater, right?
Yeah, greater than 0.5.
Okay. So then when it's greater than
We fail to reject.
p-value is greater than, we fail to reject. Okay. Yes. Okay. Fail to reject. I hope that all of this information is correct.
I hope so too.
Okay, so then we're doing that. Oh, we're going back. That 6 was 98.234. 7.
Well, 98.220. I don't know. Depending on what you're doing, if you're going to input Natalie's information or if you're going to input Sadie's and mine.
Okay. So 220. 0.922. And 8 is minus 1.843.
Negative.
9 is 0.081.
Uh-huh.
Okay. Sorry.
And based on that, we fail to reject the null hypothesis. Okay. So we got to do this again, right? using the following values, which were pulled from the data file, baby boom. These values are in wait time in minutes between births at hospital. Copy and paste them into the software. Hospital claims the average time between births is 40 minutes, and plans its resource allocation based on this claim. You want to test the claim. U is 40 is not equal to 40. Okay. Do a new one of these.
So for the p-value, I got 0.26.
Hold on real quick. Copy.
Oh, wait a minute.
Analyze. Compare means one. And our test value is 40. Move that guy over. Okay.
That's
221 and SCS for 222. Now it says in the instructions something about the quantitative inference procedures and XLS for 221 and SPSS for 222 and 223. I don't know what that means. Do you guys know what that means?
We're in the reading. What point?
No, but Natalie, when you're using Excel, are you opening up that file, the quantitative
Yes.
inference
Have
procedures
open, have
file?
open.
Okay, I don't know
Careful, Aria.
if I don't know. Okay. Let's see. Is that found in the reading?
Yeah, it's in the where you find
Oh, here we
all-
go. Yeah, but that's an Excel file only, right?
Yeah, I think so. I don't know.
Yeah, because it's an Excel SX file. Yeah, I don't know. Okay. All right, Sadie, what'd you get? Or what'd you guys get?
For the p-value, I got 0.995.
Sorry. Point what?
0.995.
Yeah, that's what I got too. Natalie, did you get something different?
No, I got that.
Okay, woohoo! We're on the same page this time. That always feels better.
Is there your answer on the top?
I can't.
Can you hear me? Sorry.
Yeah, now I can hear you.
On the very top one, number 5, you had to change the total because it's 98.6, and the alternative is less than 98.6. Did you switch that on your table for SPSS?
I did. Hold on. I changed it to 98.6, but I didn't. Let me see. Let me check something real fast. This is my new. This is this. Okay, hold on. Analyze.
Because that's what it it asks you if you switch out the sign.
t-test, it doesn't ask you for this one. Well, hold on. On the sample t-test, it doesn't ask you, but I do remember seeing something about that in the reading. Let me look at the reading.
That was the difference here.
Where did I see that? Where is that in the reading, Natalie?
I can't find it. I don't know what's in the worksheet.
I remember seeing it. I just don't remember if...
I can show you what it looks like. Can you see it?
What's that?
Can you see the Excel worksheet?
Mm-hmm.
That's what it looks like.
Okay, but we're both working in SPSS, so I'm not sure if it's different in SPSS. But I do remember seeing something about being able to change that to not equal to, greater than, and less than. But when I go in and do the sample t-test, it doesn't give me the option.
What are we trying to figure out?
If we go in, okay, so we go in and we go analyze, compare means, one sample t-test, and the one sample t-test comes up and it gives you the option to change the test value. Natalie's saying that you can change the symbol to greater than, less than, or not equal to.
Well, I didn't on SPSS. So for the test value, I remember that was less than. So I used 30.
Oh, is that what you did? Okay. I just put in the test value, like 98.6.
And so, it looks like I used 30. 30 value was point. And so I said the p-value decreased.
Functions. I know I saw that in the reading. Where did I see it? Natalie, you can't find it in the reading?
I can't find it in the reading.
Okay, here we go. T-test. Move the variable containing your data into the t-test. Your null hypothesis will state that u is equal to some number. Enter that number as the test value. Okay, so we don't have to worry about it because we're just entering the null hypothesis. So it's always going to be equal to in the null hypothesis. So we don't have to worry about changing it to greater than or less than. Right? Because we're not entering in the value for the alternative hypothesis, just the null. So that's not something we need to worry about changing.
Okay.
Per the reading, per what I'm reading right here, it just says your null hypothesis will state u is equal to some number. You enter in that test value. Don't forget to do this. Click OK. The output will contain a box of the one sample test. This will give you the test statistic, degrees of freedom, and then the p-value. Okay, so I think we're good.
Okay.
All right. Let's go back to what we were doing then.
Okay, so sorry, 11 is 0.995?
Yeah.
Okay. So 12 we failed to reject.
Yeah, because it's greater than, right? Okay, so this time set it to 40. And that's not information I want. This time you use, and you keep the same level of significance. Hold on.
Is that what we're just talking about?
One simple t-test, test value. Oh. I don't know, did the p-value increase or decrease? I don't know about that one. What do you guys make of number 13?
I want to say.
Okay. Hold on. How? Okay. P-value in the area of 2 tells us. In other words, the p-value is equal to. Okay. Here we go. The p-value in the area in the tail to the left. Oh, we just have to divide it by 2.
Divide what by 2?
Okay. So for the reading, if the the sigma two-tailed is our p-value, when our alternative hypothesis is anything other than not equal to, we take that number and we divide it by 2.
So take the original value and divide it by 2.
Yeah, because it says the p-value is the area in the tail to the left of the statistic, the two tails. So it's giving you the amount for each side of the tail, like together, right? Which gives you the area of both tails. Then adjust it so that you can get the area of the left tail. Usually this means you divide by 2.
But I don't understand what you're dividing by 2.
The p-value.
Okay.
That number 0.9, where is it?
0.995.
Yeah.
It gives you 0.4975.
So the p-value.
So it decreased, right?
Mm-hmm.
It decreased.
Oh yeah, if we have to divide it, it's going to decrease.
Yeah.
But it's still greater than the level of data.
So then we would fail to reject.
Mm-hmm.
Okay. All right, compare the width of the confidence interval for question 11 to the confidence interval for question 13. Which one is wider? Oh.
11. Okay.
Yeah, 11 has to be wider, it's greater.
Right. Yeah. Yeah, 11. Right? Compare the width of the confidence.
Okay, how are we submit?
Natalie, do you agree with that for 15?
But if you guys think it's,
I can't hear you.
I'll go ahead and put 11. I don't have an answer for it.
Okay, you're not sure about the answer on that one. It's still we're still dealing with a 95% confidence interval, right?
Yeah.
Oh, so they might be the same.
That's what I was thinking. I don't know. Oh, wasn't there one on the practice, the preparation assignment that was like this? And I think I was like rolling it over. No, I think it was a question. No, I was rolling it over in my brain, I think. Like, oh, maybe there was one. Maybe there wasn't one.
I'd say they're the same.
They're the same?
Yeah.
Yeah.
Okay. So
Okay.
go with there.
Okay. All right, we'll go with the same. All right, you ready?
Yeah.
Submit. Oh, please. Oh, 88%.
Woohoo.
So we got number 9 and number 10 wrong.
I wonder.
So that would mean value is smaller than what we have. If they reject their hypothesis.
So then maybe my p-value was wrong? What'd you say you got for that one, Sadie? You got 0?
Yeah.
Why would that be different? Why, I don't understand why everything else in your one sample test would be the same and then...
That one thing different.
Yeah, that one number would be different.
What was the 90?
That's weird.
What were we using?
98.6, right?
Okay.
Right?
Yeah.
98.6.
You know what? 9. Well, actually for 10. Because actually 9 was less than the 5 we needed. The 0.5, because this is the 0.08. So that's why we got 10 wrong.
You're saying 0.08 is less than 0.05?
Oh, it's 0.5. Never mind. I probably got it wrong because we just got the p-value wrong.
Yeah. For some reason that number is wrong. Sorry, you guys.
It's okay.
That's okay.
What did you end up getting for the p-value, Nally?
I already took it.
I
You closed out.
changed value and I got 0.081.
Oh, what'd you change the test value to?
The 6.
98.6? What the heck? Okay, let me do this. Oh, that's the wrong one. I want that one. That is weird. Okay. No. It's not the one I want. I keep bringing up the wrong one. There we go. Okay. So you just changed the p-value, or the, sorry, analyze. Analyze. Means 1 simple test. Variable is already available. And you changed, and it was at 98.6, right?
Yeah.
Okay. And I still got the same answer. That's weird. Okay, I'm sorry. I don't know why that did that. Sorry, ladies. Well, maybe we can email Brother Balls and see what the correct answer was.
Yeah.
Okay, well, whose turn is it next week?
I'll take it next week.
Okay, sounds good. All right, ladies, we'll see you next week then.
Have a great week.
All right, you too.
Okay. Bye.
Bye.